Morning. Today we're going to talk about the line of best fit. We're going to be looking at some scatter plots. We're going to develop some scatter plots. And from those scatter plots, we're going to be able to make some prediction based on our data. Right, so the line of best fit. The line of best fit, or a trend line, is the line that represents the behavior of the data. All right, so if the line is drawn evenly throughout the data, it represents the data, and we can make predictions from that. So let's look at two examples here. Here I have popcorn sales. I see that the price of popcorn sales is on my x-axis, and that determines how much popcorn is sold. All right, so if you look at our first example here, would this be a line of best fit? Does it evenly go through the line? Does it show the trend of what's happening with that data? I'm going to say if this pen was a line drawn through that data, you can see that it's not going to be a horizontal line, so A would not be a good choice. C does kind of represent what's going on. I see that as price increases, number of sales of popcorn decreases, but I've got more of my data shown on top. I'm thinking that the angle or the slope, not the angle, but the slope of that line would be more like this, so that's not a good representation. When I look at B and D, between B and D, which one do you think represents that line, the line of best fit? I would agree. I agree that B would be a better choice because I have almost an even amount of data above and below. Now these are outliers. These are kind of not going with the trends of the data as much. So if you kind of ignore some of what's going on there, it looks like it's evenly spaced, whereas this one I have a lot more data underneath the line, and I think still that line is going more like this rather than that way, so B would be a better choice. Let's look at an example. If I'm given data and I'm given a scatter plot, I've already got my line of best fit drawn, and from that I want to make a prediction. So as you can see, this is post-high school education salary. It's showing me that the number of years of post-education after high school that I get, and this is the beginning annual salaries, what I would expect to get as a beginning salary. And these are in the thousands, even though my graph is numbered by tens, and the number of years is numbered by 1. So that's what you need to pay attention to when you're kind of determining what your slope is. So as I look here, I see that as the more years of education after high school I get, the higher my salary would expect to be. Right? So from that I'm going to make a prediction, but let's go ahead and get our equation. So let's talk about a few things. Well, this line right here, I see that it has a positive correlation. As years increases, beginning salary increases. So it's a positive correlation. If I want to determine the slope of my line, we've done this before. Slope is rise over run. I had to rise 30. Remember, this is going by tens. So I had to rise 30 and I ran 4. Okay, so my slope is 30 over 4, which gives me 7.5, or we know that this is in the thousands, so it's really 7,500 per year. Okay, so what does that mean? It means that my beginning annual salary increases by 7,500 a year or per year of post-high school education. All right? What is my y-intercept? My y-intercept is where my line crosses the y-axis. Well, here I see that my line crosses the y-axis roughly at 10, really at 10,000. So I'm just going to use 10 for my y-intercept is 10, but when I'm stating what does it mean, it means that the initial salary, beginning salary of 10,000 right out of high school or with no post-high school education. All right? Now here's where I'm going to make a prediction based on my line of best fit. It says, about how much should you expect to make annually if you have 7 years of post high school education, right? So let's write that equation of the line and plug in 7 to find out what would I approximately or expect to make, right? So my line is going to be in the form of y is equal to mx plus b. I know my slope is 7.5. I know my y-intercept is 10. I'm plugging 7 in for x, which is the number of years. So I get 52.5 plus 10. I'm going to add 10, so I get 62.5. What does it mean? So remember, this is in thousands, so I've got to change it to thousands. So 62,500 would be approximately how much you would expect to make annually. Now you have to say approximately because this is a prediction. Is that always going to be true for every situation? No, it's approximately. What do I predict? Prediction is approximate. We can't say it's a real value. I mean, we can't say that is the exact value. It's an estimated value or estimated amount. Okay, so approximately 62,500 annually would be what you would expect to make with 7 years of post-high school education. Let's look at another example. This example, I'm going to use my already worked out problem to discuss. I am including one where you can try it on your own. Okay, so the first thing you're going to need to do is we're going to look at this data and figure out what's going on first, because I'm going to have to label and title and label my axis. Okay, so years of birth. If you were born in 1900, you would expect to live till you're 44, life expectancy. Okay, and so here we see 1910, 47. Does that mean you're going to die at that age if you were born that year? Not necessarily, but that's based on the data, what they were seeing, the trend. Okay, all right, so anyway, here's my data. So years of birth, year of birth, the year you were born, and then the life expectancy. So year of birth would be your independent variable, because based on this data, that's going to determine or the life expectancy. So that's going to be the dependent. So independent variable is year of birth. Life expectancy is the dependent. Dependent goes on the y-axis. Independent variable goes on the x-axis. All right. So we're going to label it. I've already got one done to save a little bit of time. You're just going to follow along, but you, after you watch this video, go back and try it on your own. Okay, so I labeled this life expectancy based on the birth year, right? For my x-axis is the year of birth, so I'm going to put that here. Year of birth. Okay, and I did number these or by the year, but really I'm going by 10. So I put that in parentheses because we're going to need that when we start making predictions. But these are the years that is in our data. All right, I numbered my y-axis by 10s, and I labeled that life expectancy just based on my data. I applied those points. I drew my line of best fit, best I could, to go through, represent that data. All right, so let's start off. Draw a line of best fit. I did that. Find the slope of your line. My slope is always rise over run, so I picked 2 points. I picked this point here, and I picked this point up here. So I rose 30, and I ran 7. So my slope is going to be 30 over 70, which is equal to 3 over 7. So life expectancy, my slope is 3/7. So what does it mean? That my life expectancy increases. Life expectancy increases 3 years for every 7 years of birth. So it increases by 3 years for every 7 years. For every 7 years of birth, let's say I think a better way to say that is for every additional year. Okay, let's just say that for every additional year. You could have used your decimal and explained it that way too. I'm just going to leave it this way though, as a fraction. Alright, find the y-intercept. Well, where did we start our data? We started our data at 1900. Year expectancy there was 44. So my b is going to be 44. And what does that mean? That means that let me change this. 1900, the life expectancy was 44 years. That's basically all it's saying. Alright, so now I'm going to write my equation. What is the equation of the line? I'm going to substitute my slope. I'm going to substitute my y-intercept. And I get y is equal to 3/7 x plus 44. Alright, what is the correlation? Well, it's a positive correlation. Look at my line. As the years increase, life expectancy increases. Alright, so at what age would you expect a person to live in on average by the year 2000? One thing you could do is if you go through your graph and you look at year 2000, we'll be right here. So roughly, if you were looking here, you might say about 85 or 87 or so. But if I wanted to find it algebraically, I have an equation. I'm just going to plug in. The year 2000 really on my graph is 100, because from 1900 to 2000, that's 100 years. So I'm going to put in 100 here. Y is equal to 3/7 100 times 100 plus 44. I'm going to do the math, and I find out that the life expectancy would be 87. I'm using approximate because it's a prediction. It doesn't mean that everyone who's born in 2000 is going to die at 87. So this is just a prediction. So I have to say approximately 87. If Sam died at age 59, approximately what year would you guess he was born? I can make an educated guess by looking at my graph. So in 1930 is right here. If I go up, roughly about 50 is a little bit more than 55, so maybe about 56, 57 or so-ish that I would expect that his life. I'm sorry, I looked at that the wrong way. At 59, I'm going to go here and go across, and actually, I must have been looking the wrong way. At 59, it's going to be about right here. Nope. At 59, approximately in 1930 would be when I would expect that he was born. So that's correct, in 1930. So we can use our graph to make those predictions. We use our trend line that we developed. Like I said, I attached another sheet for you to practice, and we'll talk more about it on Tuesday. Have a great day.